Welcome to the Resilient and Adaptive Toolchain relying on the Eclipse Arrowhead framework demonstration. This is Salman Javed speaking from Lille University of Technology. This demo represents the work of Aparajita Tripathi, Jaime Garcia, Emmanuel Palm, and myself under the supervision of Yanwan Juventus and Jerkel Delsin. The motivation behind this work is to develop an adaptive toolchain system of systems integration using the Eclipse Arrowhead framework based on local clouds. It provides the automation of the information processing and transmission throughout the engineering process at design and runtime. It also ensures runtime dynamic adaptation and the behavior of an application system in response to changes in its operating environment and guarantees resilience to minimize the undesirable consequences of an incident. Researchers at LTU joined together to showcase the Arrowhead toolchain integration of business negotiation, workflow execution support, manufacturing operations, robot, and smart building automation in an Industry 4.0 use case. A tool chain is a collection of tools and definitions of their associated interfaces structured in a parallel or a chain. Tools in a tool chain with identical input-output interfaces are interchangeable. A tool chain facilitates the reuse of its constituent tools and tool chains. A tool chain may consist of only a few, not necessarily consecutive stages of the engineering process, for the whole product lifespan, typically of generic infrastructure products, even iteratively up to the end of life phase. Eclipse Arrowhead framework toolchain is represented uses RAMI 4.0. It integrates from business layer to asset layer and from product design to the whole manufacturing and maintenance life cycle. In this demo, we have integrated multiple Arrowhead compliant systems like contract proxy system, workflow system, OPC system, ZWave system, and ROS system that cover most of the RAMI 4.0 reference architecture of Industry 4.0. Dynamic adaptation describes the capacity of an application system to adapt its behavior in response to changes in its operating environment as it executes. A resilient cyber-physical system of systems provides the ability to minimize the undesirable consequences of an incident. It mitigates most undesirable incidents and restores normal operation within a short time. A resilient system ensures robustness, resourcefulness, redundancy, and rapidity, where robustness is the ability of the system to function under degrading performance. Redundancy is the identification of substitute elements that satisfy functional requirements in the event of significant performance degradation. Resourcefulness is the ability to initiate solutions by identifying resources based on the prioritization of the problem. And finally, the rapidity is the ability to restore functionality in a timely fashion. The demo consists of four Arrowhead local clouds. So the first one is a Z-Wave local cloud on the Raspberry Pi. Then we have a contract proxy workflow and OPC systems local clouds. Then we have a Fisher Technique factory and ActiveMQ broker system on a Raspberry Pi as well. Then we have a ROS local cloud. Then we have an OPC PLC and a ROS robot. Then we have a few Z-Wave devices. First of all, it's the milling device with uh, for indicating the milling process. Then we have a primary milling device indicator. Then we have milling actuator and the drilling actuator in the factory. Then we have drilling process indicator light as a primary. And then we have a backup drilling process indicator light. The Eclipse Arrowhead framework toolchain here provides the integration across the product design to manufacturing lifecycle and from asset to the business layer. So the contract proxy negotiations and OPC workflow systems are integrated in a sequential toolchain where as the ROS robot and Z-Wave building local clouds are integrated with them in parallel. So here we can see that the sequence starts from the buyer and then the buy in the contract proxy system local cloud. buyer requests the contract proxy buyer for asking the negotiation to the contract proxy seller, and then when there is an agreement between the contract proxies, then the seller generates a workflow order to the workflow system local cloud. And while the manufacturing phase is going on, the ROS robot and the Z-Wave adapter system, they are working in parallel, and they are uh, forming their functionalities. So the toolchain demonstration, uh, in this demonstration, the buyer starts a negotiation with the seller using contract proxy systems, and upon successful negotiation, the seller system requests the workflow system to manufacture the product. The drilling and milling process of the factory is integrated with the Z-Wave light bulbs to indicate the process execution phase, respectively. The ROS robot picks up the product from offloading conveyor upon successful manufacturing. Toolchain demonstration with resilient and dynamic adaptation. In this video, This video shows how a zero system is resilient and adaptive upon a failure in primary light sources responsible for indicating drilling or milling process. It switches to the backup light sources at runtime. Once the primary light sources are back online, then it dynamically switches back to the primary light sources from the backup at runtime. We hope you enjoyed the demonstration of the Eclipse Arrowhead toolchain. If you have any questions, you can contact me at salman.jvd@lq.se. Thanks.